Okay, we're close to getting done, so I just want to finish this tonight. So, so currently we have this cube moving and rotating, but the rotations are currently incorrect. For instance, the bottom left corner of this cube should remain the same when we move it to the left, but it doesn't, it dips down. And that's because the center of the cube is moving in a straight line instead of going in an arc. So now we're going to just change the animation direction so that, well, yeah, we're going to just change this part so that in the animation the center of the cube moves in an arc instead of in a straight line. So let's do this. So if we go back to the animation, I think it's called like direction. Yeah, we want to fix this to do part here. We want to change this with something that computes the center of the cube. And then after that, we'll make this somewhat sensible. So I think similar to the theta, similar to like the calculation of the matrix, we're going to have to do something using some trig. So let's see, the center of this cube when it moves is going to form a diagram needed. Let's just create a diagram to figure out what we need to do. So can I zoom in? Okay. So let's say that our grid is kind of like this, and our cube is here to start with, and then it's going this way to, let's choose a different color, to here. Then let's see, the center, if this center here is remaining constant, then the center is going to move in the arc of a circle. Moreover, if the angle over here is, the angle is 90 degrees. That's the main part, right? If this angle here is pi on 4, I can even write that. And then the angle here is pi on 4. Okay. In either case, this just means that the arc it moves in is going to be that. Okay, so in order to calculate this arc, we can just use the old sine, cosine, parameterization of this. Cosine theta, this vector, sine theta. But we need to know the value of this radius r. And so in this case here, the radius is just going to be this thing. So it should just be half of this hypotenuse. If this is 1 and this is 1, the entire hypotenuse is √2. So this should just be √2 divided by 2. Okay. So with that in mind, then, can I move this to like the top? We just need to put that into code. Okay, also like the direction itself is, let's just start with the left direction, and then we'll figure out how to adjust this for the other directions. So we also want to refactor this so that we're actually just calculating an offset here. So let's change this to animation offset. Currently we're doing it via this thing, but we want to do something different. Let's move this up here. This part's actually like, there's actually no need to do the splat multiplication with all of these, since two of those multiplications are multiplying by 0 and won't have any, it will be irrelevant. So we just want to, let's just say like reciprocal fraction, or like reciprocal animation fraction is equal to 1 minus the animation fraction. And then we just want to say multiply each of these by this RAF. But multiplying by 1 is just the same as the RAF. Okay. And then in this part where we see this animation offset, well, we determine that above. So let's check that this still compiles. Zig build run. Let's move this over here. Okay, that still looks like it's working to me. Okay, so now let's modify this to follow the formula. Okay, so in this case here, we're going to have to modify the y now. Instead of just moving in a straight line, we want this to actually be, it should just be like cosine of theta, and let's move the theta up here. Yeah, we won't need the raf actually. It would just be cosine theta and then multiplied by the square root of 2 over 2. So let's just say like, does the compiler have a square root of 2 built in? Why am I searching Odin? We're doing Zig here. Square root 2. It does. Great. So let's just say like constant radius is equal to standard.math square root 2 times 0.5. Let's just call this like a big R. We should also describe what we're doing. The center of the cube during rotation moves on a circle of radius r, which is square root 2 divided by 2, from angle, let's see, pi on 4 to pi on 4 plus half, so 3 on 4 times 3 pi on 4. Okay. Done. So now we're doing radius times cosine of theta, but now we need to add on this offset. So let's just say like hang on. So theta is moving from pi to pi on 4 anyway. So, no, wait, shouldn't theta be moving from 0 to pi on 2? Yeah, I feel like it is. I feel that, yeah, we already did that. Okay. So we simply need to offset it by pi on 4. So we can just say pi. Okay, I take it back. There's no need for a constant. Okay, I take it back. There is. let's just do like theta 1 and theta 2. And theta 1 is the usual version. Theta 2 is the animation fraction, but now we want to add on the appropriate proportion of pi. So it's still is just theta 1, but now modified by adding 0.25 times pi. Okay, and then theta 2 is what we want to use here, and then theta 1 is what we want to use in this matrix down here. So we'll make this theta 1, and then here we have r cosine of that, r times sine of theta 2. And then we okay, let's do this one. So for the left one, where's the image? Okay, so when we move it left, we're moving. Actually, we need to consider all of this correctly with the axes. So pressing left is rotating it. Moving left is moving the center upwards along the z-axis, but because of the fraction, when we're winding the animation down to 0, we're starting it. If it ends here at 0, then it needs to start over here. So then likewise, when we move it left, we want to make it that what's happening to the pi here? The pi is ending at 0, so we're kind of doing that, but we want it to be inverted. So we want this to be a positive sine theta 2, and then a negative cosine theta 2. I think the best way to verify this is simply compiling it and checking. Okay, and yeah, we don't know what this graph is yet, so let's just make these other ones 0 to start. Okay, and it's hopping, but not in the right direction. It's like, okay, so I think this means that we just need to invert these actually. So if we have a cosine here instead, we might have to go back to the diagram. Okay, this looks better, but there's still like a weird hop happening. The camera angle is weird as well. Let's change this back to what we had originally. So I think if we have this initial camera position here, let's move it back to like the 6, 6, and the 6. It's hard to exactly determine what's happening. Okay, and okay, the offset is now going in incorrect directions, massively incorrect. It seems to be right there, and then so what exactly is happening with this? So we're saying yeah, like I don't understand what just happened there. So when we're doing it right, in which we're not doing any offset, we're just immediately moving it back. And let's slow down the animation time. That's the is it animation length? The 0.2. Oh, there it is. Let's just increase this back to a 1. Okay. Like sometimes I forget. Yeah, we have complete control of our program, so we can see what's happening. Okay. So it's like getting nudged like up and then okay, so there's like a jump in continuity between where it's starting before the animation and then the animation. Like it gets knocked up and then it does it gets like knocked up and then it does the thing. So part of the Y offset is incorrect. Right, because yeah, because when theta here starts at oh yeah, the diagram says it all, right? When we're already drawing the cube, we're drawing it assuming we're already offsetting it by a half. But this thing here is like adding in like an extra Y jump before it does that. So what we actually want to do is like subtract, we kind of want to zero this off. Like we need to center this so that the arc actually begins kind of at the origin instead. Okay, so then we then want to subtract from this, let's see, no change in the x direction, but then basically like this root 2 vector in the y direction. So in other words, R and R here. Okay. Yeah, let's get this together. Oh, what? Oh, yeah. Okay, this looks better, but there's still some weird discontinuity happening. Like it's getting shifted. Wait, what? Why is it getting shifted? It's now not getting shifted vertically, but there's still some weird X shift happening. Ooh, yeah, what? But it still goes into the correct final place though. Why would this be happening? And like after the shift, the bottom edge is correct. Is still, well, I think. Wait, it's hard to tell. Oh no, maybe it's not. Maybe no, yeah, the edge itself is moving, but it should be solid. Okay. Oh, maybe. Okay, let's just go back to this diagram again. What's going on here? No, it's still not clear to me what it is. Okay, like by how much is it shifted backwards? It's not halfway, that's for sure. Maybe the easiest way to see what's happening is to actually turn off this part, to switch off the animation matrix, or at least make it 0. So when we're going left, let's temporarily we'll temporarily make this the identity matrix, but we do like mat30, what is it, ID, was it ID F32? I think so. Okay, yeah, this is, we can at least kind of see what's happening more clearly now. Yeah, definitely like a discontinuity. It should be rising directly from there. Okay. So what's happening? So when this animation starts, let's remind ourselves. So we get the elapsed time. We then we then get like a fraction that goes from 0 to 1. 1 is when it's finished. We should write this in. Fraction is 0 at start of animation, 1 at end. 1, yeah. And then we just have to like do some ugly cast because we're doing Z11, and then okay, and then this thing is now ranging from this thing here. So we're using theta 2. So if theta 1 is ranging from 0 to pi on 2, it's ranging from pi on 2 to 0. Okay, then pi on 2 to 0 means yeah, 3/4 pi to pi on 4. And then oh, is it simply because we're not multiplying this by the r? I think that's it. How did I not see that? Okay. No, okay, now something else is wrong. Like, is there, what is going wrong? Okay, let's okay, yeah, when I'm subtracting the r here, it's basically, okay, if we were to actually draw the arc all the way to the circle, I'm subtracting that much instead, and there's like this extra part I'm subtracting, yeah. So really what we actually should be subtracting is the we want to be shifting this to this, and in order to do that, and we need like a new diagram. Yeah, let's just like clear. Can I just do new? Don't say. Okay, now I get it. This was a very silly error. Okay. So yeah, so this is the R, and currently the offset is, the offset is here. This is the odd, and we want to move it to here. So we need to apply a vector to this. The vector is not like RR or like RR. A very fun film. The vector is, we're gonna have to calculate the length of these blue sides. So trig, right, tells us that the this angle here, which is pi on 4, or just like theta dash, that cosine of theta dash is this length divided by that. So the actual length is going to be r times cosine of theta. So really we want to be here subtracting from this Okay, sine of theta, because actually by theta here we really just want pi on 2. So 0.2 times pi. And then here we want r of cosine 0.25 times pi. Okay. Let's give this another go. Binary has white space on one side but not the other. Where? I'm not seeing it. Oh, I guess I need to. Okay, curious. Wait, I'm literally not seeing this. What's the number? 75. Okay. Here apparently, but there's space there. I just didn't save it. That was why. Okay. Okay, and now there's no offset, and it does move correctly. Great. We figured out the bug finally. Okay. So now when we turn back on the rotation, stuff should work out. Okay. Yay! And now it's like it looks like it's doing it correctly now. Yep. That is beautiful to see. It's working. Great. Great. Okay. So now let's get all the other directions correct as well. So animation time. Let's move this back to 0.2. And then okay, what are we gonna have to do here? So this is an arc which is going from like the origin to something else, and now we want to kind of do it in reverse, but I feel like we'll have to shift that slightly. How will we shift this? So now we want to say negative theta 2, negative theta 2. And what happens in this part here? So now we're doing that way, and now we want to center that at 0 again. So now we actually need to go it would make more sense if we make this a plus and then add in the minuses here. So likewise, we're adding this vector, which is we're going negative down and negative this way. Now we're going positive in the x and negative in the y. Okay. Let's give it a go. This is fine. Okay. Snappy, but not correct. Okay. Why? We're going to have to just return the animation time back from 0.2 to 1. So like the alignment looks fine, it's just the actual animation. So oh, but why is this not rolling? It's meant to be rolling to the right anyway. Why is it rolling the wrong way? Okay. So I think this part is the part which seems kind of wrong. And like, yeah, why is it like ending upside down? This is so weird. Okay, so then if it's ending upside down, currently it should be... Like what are we doing? I think adding in the negative theta here was the wrong move. It's just that instead of... I think we just want the offset to be negative in both of these directions instead. Okay, that looks better, but not correct. So now it's like dipping under instead of dipping over. I do kind of like the way that moves though. This does seem to be moving in a fun way. But yeah, there's something weird with the offset as well. This is... The approach is not just like brute forcing it. The approach is just actually having a conceptual understanding what's going on, which is clearly not happening. Let's just like annotate what's happening to all of these stages. At t equals 0, theta 2 is equal to what? We can actually just work this out with the print statement, but I don't want to. So the fraction goes from 0 to 1. So theta 1 here goes from pi on 2 to 0. So this must be 3 on 4 pi. At t equals 1, theta 2 is equal to 1 on 4 pi. Okay. So then yeah, so when we're pressing left, like yeah, the center is going in the correct direction, and the rotation is going in the correct direction. This rotation looks like it's going in the correct direction though, it's just the center that is off. So we don't need to worry about this, only this part. So yeah, what do we do? So we have to move the origin of the arc from positive x, positive y plane to 0, which is what that does. And then this part is doing 3 on 4 pi to 1 on 4 pi. Like where else are we? Okay, am I just doing it done? Right, because a 1 on 4 pi is this stuff here, and so we're basically at time equals 1, this cancels with this. So we want to do something similar. At time equals 1, this needs to cancel with this. What happens at time equals 0? Time equals 0, we want this to be like a full quarter. Okay, why does this work when this stuff cancels at 0? Okay, because we've already shifted it up. So then, right, so then at time equals 0, we want to like push it, we basically like pushing it backwards. And then we're pushing it backwards to start at the full thing, and then we're bringing the amount of it backwards forwards. Okay, so similarly here, at time equals 0, we want it to be like a full length backwards, and then we contract that length down to 0. So so then to do that, we want is it just a, do we truly I think we just want a negative sign in front of this then. So we actually, let's keep these the same. But now with a minus sign, if the Z compiler likes it. I don't know if it will. Actually it won't, it will whinge. So we do want a negative sign in front of both of these. But now, when this is 0, we need this to cancel out. And so in order to cancel out with it, we just want this to be like a positive R. And okay, but if we want this stuff to cancel out, the easy way to indicate this with code is just to like have the symbols almost the same. So let's just do the same thing here. Okay. Let's see. That works, and then the moment of truth. Not yet working. Why is it dipping down instead of dipping up? I think it's because, okay, we're inverting the Z direction, but we want to still keep it up. So we want to actually keep this part positive. Okay. But then that means we need to change this part to be positive as well, to have them cancel out. Compile. Okay, and now it's working again. Okay, well, not again, it's working, period. Oh, but there's like a discontinuity. Did I? No, it's fine. The discontinuity is because I'm clicking it quickly. Okay, yeah, that is working. Good. Okay, instead of making the animation quick and then running into the exact same issue, let's use the slow animation to get the up working now. So the up is doing what? The up is first of all rotating in the wrong direction. So let's fix that. So the up should is the down not working as well? That's fine. Oh, what am I talking about? The up is working right. It's just the offset that makes it look weird. Okay, it is, the rotation's fine. It's just the offset problem again. Okay, so now, yeah, so now what's happening? So now we're moving this animation stuff. First of all, we're moving in the X direction and the Y direction. So the third argument of everything in here should be 0. Okay. Then the Y directions should still have the sign, but now it's the, okay, so we're still, yeah, so instead of 0 sine cos, it's now going to be cos sine 0. And then let's think what's happening again? So at time equals 1, theta 2 is pi on 4. And by this stage, we want the arc to have gone back to 0. So when we push it forwards, what we're actually doing is shifting it back which in this case means positive x direction, and then playing the arc. So shifting it in the positive x direction means, yeah, we want cosine of theta here, 0 negative theta. And then we want to cancel that out the same way we've been doing everything else. So in order for this to cancel, yeah, this should just say the same thing as this. So we want r times cosine of 0 of pi on 4. Why did I have like 0 here? It's meant to be this. Yeah, r times sine of this, then 0. Okay. Let's see if we're third time lucky here. No, but almost. If we were going down, this would be the correct offset. Yeah, it's doing the going backwards thing. So let's actually just copy this into the down now, and we should have now got the down for free, or the down by accident. Okay, the down is working. Great. Let's now fix the up. So this was like it's nice that we're actually animating this with trig and not with ridiculous overcomplicated software. That would be inaccurate. But it's hard. It's not easy the first time around. Yeah, so let's see again. So when we're pressing down now, the reason it's working is it's like being offset in the negative direction. But we have this being positive though. So like when I press down, the cube is instantly moved to there, but then we're moving it again. We're moving it backwards, which is in the negative x direction. So why? Like what's happening? Why does this work with this positive instead of negative? In either case, I think the answer is just the thing that will make it work is by adding a negative sign here and then a negative sign here. But I'm still unsatisfied because I don't, there's just one piece that I'm not getting. Okay, that now seems to be working. Let's change the animation time again. Did I save it as A? I did. Okay, the cube is finally moving correctly. Look at those edges stick when it rotates. It's so crisp. And as always, we can now we can rotate it as we can hit the buttons as fast as we want, and it works. The animations all work out. Okay. Before I move on, I need to understand this. Like why? Why is the negative sign here the thing that makes this work? Let's stop making this full screen. Okay. Hey, yeah, the animation is kind of. It's looking good. I'm happy with it. This is what I wanted, and it's just some trig. Deriving the trig, not easy, but it's there. Yeah, I still want to understand this up. So like pressing the up key. Like the cube immediately gets transported to the part above, and then. So then when we're playing the animation, we're then like moving it backwards. But moving it backwards is along this x direction is the plus. So then why is this a negative instead of a plus? I don't get it. Oh, it's because cosine of theta. It's because cosine of theta 2 at 3/4 pi is negative. That's why. Okay. Problem solved. Let's save what we've done. And why do I keep like killing that when this is like. This is like the good one. Okay, what did we add? Div. Yeah, we did all of that. Finally, I got correct cube rolling animation. Okay, off to GitHub this goes. Yeah, this is. I'm happy with this. This is fun. Blah 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 blah. Roly. Okay. The rest of the code though is really messy, so we should clean this up a lot. Okay. Why did OBS just disconnect? Come on. Okay. Connect it again. So I think one of the things to clean up is just these cube colors. Like, there's no need for all of these faces to have different colors. That was just like a debugging thing. So let's first change that. So I think I did like a struct cube. No, where did we define this? this cube is defined using colors. Where is it? Where is it? Okay, it's defined using 6. Like there it is. Okay. So yeah, I think this is unnecessary. We should just get rid of this, and I think we can just get rid of all of these. Yeah, let's get rid of all of these unnecessary. We want to simplify this code. So if we go to the render, the general render, for all of this stuff, why don't we just add the color as the first argument? And then for the cube that we're doing, we want this to be yellow. We want this to be red, green, blue. Yeah, the stream just like disappeared for some reason two-step, but like hopefully it's back on now. But yeah, I'm not sure why it jumped. Oh wait, is it not? Has it stopped working again? So annoying. Why is this not working? Let's try again. Okay. So we'll do the yellow here. If it was called yellow, I think it's called yellow 2. Okay, back we are. We are back. So, I wonder actually if there's any need for these. Like these were simply for debugging, and I feel like the debugging is now over. So let's get rid of those. And yeah, like there's no like collision detection or anything in this demo. So let's get rid of that. So for these colors, I think we can get rid of most of these. Get rid of that. We just want the yellow to get rid of all of these. Let's still leave these in for debugging. I think we did actually have to assign these. But in such a case, we can just call this debug and get rid of the magenta. Ooh, we do need the white, and I still think we do need the black for the background. So yeah, we just have the black, and then yeah, thanks for joining. Bread is not good enough. Happy that you're able to see some Z code. Okay, and then let's see if this is enough. No, we are missing some things. 37209. Oh, I've already redeclared. Where's the other black declaration? 84. Okay, yeah, let's get rid of this. Then what else? Undeclared identify yellow. Yeah, because let's just change this from yellow to yellow, and then try again. 398 doesn't understand cube yet because we're doing stuff with the color here. We will need to rewrite some of this stuff then. in particular, let's see, yeah, we are using debug color here, and then actually this part here is unnecessary, I think, and that if we're copying these triangles to like all of the faces of the cube that we're drawing, so really this should just, both of these should be the colors, and then in the later parts where we assign where we like change the colors, we can remove that stuff. So where's like the color change part? Where else do I use colors? Here, this stuff can go. Okay, let's try again. Yeah, things are going pretty well. Red is good enough. Thanks for asking. Yeah, I basically like started a couple days ago just wanting to animate a cube like we're doing now, and we're doing it. Some things like the grid looks slightly off, but that's because the grid is being drawn. That's because the cube has the center that's the origin, and the grid is going through that origin as well. Okay, we should adjust this. We should move the grid down to the appropriate amount. So, this is just like a general Raylib function I'm calling. Maybe there's like a more specific version of this. Draw grid, or is it draw grid? No, that's kind of it. Okay. To make things match up, then we could just shift the origin. It feels a bit weird. We just want to add in a like 0.5, 0.5, 0.5 offset to the cube. I guess that's fine. Should we do that? We shouldn't do that in the render. We should actually do that in the cube position. So I guess we should do that here. Add in 0.5 offset so that the origin of the cube is, so that the center of the cube is not actually the origin. So yeah, two-step says, did you have some issue where angles were off by 45 degrees? I'm messing around with Raylib here and having that issue where I have 32 angles stored as radians. Yeah, there were issues where things were like not aligned, but I think this was just like a conceptual issue and me making some mistakes. Like the I feel like things are working. It was just my initial attempts were incorrect. Yeah, so now we want to say cube pos f32 plus equals vec 3 0.5. Well, hang on. No, this should be fine. We should be able to do this. Let's try again. Okay, and now it looks like it's on the grid perfectly. Great things. We can make this like even bigger. Right, it's all snapping. It's all rotating as intended. Great. Okay, let's add this in. Git add main. Remove debug cubes. Made cube actually kind of walk on the grid. Okay. Yeah, like for the, when it comes to the rotations, yeah, I made some like mistake earlier where I thought, oh, like since these like thetas are inverted, I need to like invert these ones here, but no, that was not the case. That was very much not the case. Okay. So that's, yeah, this is working. So now let's just continue this code cleanup. Okay, and let's, what's the time? I wanna finish this tonight, so we'll say we finished it here. Okay, we've done that to do, great. So now we need standard, raylib, all of these things. Yeah, these types. I feel like it's more natural to have these vectors followed by the matrices, and then colors, triangle, animation type. I feel like if we have, before global should be some constants. Constants. So yeah, what are the constants we have? Heaps of matrices. And then some of those are matrix functions that we don't want. And then we also want to add in like the couple of colors we did have. To like here. Let's add the colors first actually. Then I think the more common sense ordering for them would be black, white, yellow, debug. Then yeah, we have our identity. Okay, so some of these like identity matrix things, I'm kind of blanking if the Zig library actually had some matrix operations. I feel like we did some search this morning where it didn't, but then I'd be surprised if it wasn't in here. But I'm seeing matrix.get, so oh, but it's like typical. It's something else. So yeah, have those, have the rotation by 90s, have the rotations by Zs. Then I guess that's it. Oh, this is no longer the game demo. It's just a way simpler demo. This is just a rolling cube demo. Let's move the camera a bit to move the camera down here. This is more like window. Ooh, the window, the initial width and height are constants. So we should move these, as are all of these. Come on. Move them here. Okay, then this window title is a constant as well. So let's move that up as well. So yeah, the game globals, which is just this queue position, which initially we may as well make this 0, 0, 0. Let's just compile again to make sure it's still fine, and it's not fine. Redeclaration of yellow 72. Oh yeah. Okay. Back to clean up. This is a constant, so that should really be moved, and yeah. Where do we put this? Okay. And we have these matrix functions. So we should just describe what these are. So we could say, yeah, produce the rotation matrix that is, or rather these are just like generate matrices that rotate about a given axis. That rotate about a given axis. So then we can just say x axis rotation, and then y axis rotation. Then this is z axis rotation, and we actually don't need any other ones. So so note y axis rotation is not needed in this demo, since the y axis points up. Okay, and then like, is there really no matrix multiplication in the standard library? If we search multiplication or multiply, I'm kind of yeah, I'm kind of surprised, but I guess that's fine. It doesn't appear that matrix multiplication is in the C standard library. So here are some, here are some of the common, functions. Here are some versions of the common functions. So now we have like matrix multiplication for exact for matrices in with I8 code, I8 entries. Then there's like the same version of this, but for the F32 entries. Okay, this would be a good time to like do the polymorphism and look into it, since I haven't looked into this in Zig, but I've seen it around. So if we do like polymorphism in Zig examples. Just like give me the code snippet that I can just like copy from. Activating LLM. How do I do polymorphism in Zig? This isn't what I wanted. Like in Odin, it's with like $T. I think that's like the same in Jai as well, but not that I have access to the beta. But I've seen like something with types here in Zig as well before. Zig polymorphism examples, like, okay, maybe here's, oh, not what I was looking for. Maybe like the vector documentation describes how to do this. Okay, this is really bizarre, but okay. Let's just add in a comment. In Zig 0.11.0, doesn't seem like the language has the kind of polymorphism in Odin or Jai. Okay. So yeah, the polymorphism I want is just that this is doing matrix multiplication with entries that are I8s, and the exact same thing for entries that are F32s. And I just want to be able to say, like, compiler, recognize, yeah, this thing should just work with any nice number type, and when it compiles, the compiler goes, great, I need an I8 version of this function, I need an F32 version of this function, and then it does it. Okay, and then multiplying a vector by a matrix, and here just like scaling matrix. What else? Converting an I8 matrix to a 32 matrix, and then yeah, like applying a matrix to a triangle. Oh, maybe so generics is what I want. Okay, thanks to step. This is what I want. Zig generics example. Okay, this looks good. I think. Was like the. Yeah, this is what I want. Something like this is, yeah, this is totally it. So let's just immediately update the polymorphism I had here with there seems to be generic support. Okay. Like there's so many names for this stuff, right? Like it's templates in C++. In Odin people say like polymorphism, and in J I guess it's like generics here. Unless I'm like confusing polymorphism with something else. Which I may be. So okay, so how could we turn this into to use generics? Let's look up the documentation. Generics. Oh, there's only 2 times the word generics appears in the documentation. Not what I was looking for, but maybe that's okay. Okay, so you can actually just define like a max function like this. And so in this case, what we say comp time t, because you have to know types at comp time, and then okay, let's try and write a like generic version of this then. So we want to say matrix multiply t, comp time t, and then just okay, then the matrix type. So now matrix 1, which is a type 3 at vector 3t, and then a matrix 2 that's of the same type. Then then we need to return another matrix that's of, well, then we're returning something of that type. And then I should be able to copy most of this stuff. And then, okay, so yeah, the value return is just this 3 at vector 3t. Undefined, iterate over this thing. The sum is now t. Do that thing, do that thing. Okay. Let's try and compile this. No. 180 missing. What's the issue? Oh, I guess I need to say t is a type. Yeah, okay. The type of t is type. Let's ignore Russell's paradox for a moment. Okay. Okay, great. So now let's replace some of these with matrix multiply t now. So let's go to like this one. This looks like a perfectly fine one to try it on. Matrix multiply t. You also wrote a gist. Thanks. Let me just like pull up your link on the screen. 2-step. Is it like this? Is it like this one? Stream manager. Where's the link? That one. Okay. Oh, nice. Okay, yeah. Some ways to do vectors of an arbitrary type. Very nice. Okay, let's like bookmark this, I think. So we can say like vector zig in intrinsics vectors. Okay. Great, thanks for that link. Okay. So, okay, back to this error. What's happening? Expected 3 arguments found 2. Yeah, because we forgot to mention that this is an F32. Oh, and it's working. Great. Yeah, thanks to Steph for letting me know that intrinsics do exist. Okay, so now let's just like completely clear out all of these other matrix functions we have. What was it called? What was the first one? Like matmul. Okay. Instead, what if I just say, instead of actually rewriting all of that, why don't I just say this thing is now equal to mat multiply by t, but now, oh, okay. So one thing you can, I'm trying to remember if I can do this in Odin. You can do this in Jai, where you like bake in a version of a function. So you could say like, I want this to just be this generic version, but now with an I8, and then like, you know, the usual things here. Is there any way of doing, no, because there's no way of doing this in Zig at the moment. Okay, that is okay. That is fine. Used in our case with t equals I8 and F32. Okay. So let's do like a replace. Let's just like search for instances of this. So we want to do matmul F32. Oh, do I not call it anywhere now? Okay, I guess I can delete it. And then for the usual mat multiply, we are using this a couple of times here. So make this a t and then an I8. Make this a t and an I8. You know the drill. T8. Okay, and then try compiling this again. Oh, no, doesn't like this. Where are these errors? 95. Yeah, all of these should be macro time. T8, comma, and still not a fan in 96. Oh wait, what? Well, what's the issue now? Oh, because I'm calling these several times. Okay, that's right. TI8. TI8. Okay, great. And the cube is still moving like we want, even when pressed really quickly. It's always fun. Silly but fun. Okay, and then let's move this back up there. Let's save what we've done so far. Git add main, git commit, added, started adding in intrinsics to example to demo, and began cleaning up code. Okay, off to GitHub. And then, now what? Okay, so in some sense, should be fine. I was gonna say, like, in some sense, like the concrete orthogonal matrices defined before kind of like could maybe be called with a generic version of this, but then that would require like some version of the sign function, like returning an I8, and like, that's not going to happen, so we'll leave those in. Yeah, so now we've got that. I guess kind of like for both of these versions, we only ever use the matrices with F32, so we don't even actually need that. So I guess that's fine. And then yeah, likewise for all of these, it's still F32. Okay. I had debug on these. Yeah, we don't need this test triangle anymore. We still need our stopwatch, and then so like maybe like then this is a constant. This should be at the very top. And this is a like camera constant, which we don't seem to have. Okay. Then yeah, try the stopwatch. Define this camera to look at the world. Let's align this. Some of these are constants, but it's fine. And then spawn the Raylib window, set it up. Do this. Okay, we finally need to like wrap all of this up in some sensible code. So, what should we call this stuff? Maybe like, maybe just called like apply animations or something like that. Because that's kind of what we're doing here. Apply animations. So now let's take all of this, and then we want to do function apply animations. Paste that in here. Okay, and then we'll have to clean that up. Let's just see if it still compiles. No. We forgot the return type. Okay, that's still fine. Still working. So now let's clean this up. I feel like the order of these should be in the same order as up here. So where's this one? Let's move this upwards to here. Okay, and then no need for that debug statement. Is it worthwhile having those in? I don't think so. Let's align these. Then we should also kind of break these up as well. And then Like the thing is like almost like these are almost all exactly the same, but I feel like they're simple enough as they are, and any attempt to like condense these in some other code is just going will be too complicated. Okay, so now applying these animations. This stuff we really need to clean up. So we everything here has to be explained what we're doing. So the first is just to calculate as a float, as a F32, the number of seconds passed since a arrow key was last pressed. That's all of this stuff, and now and then we want to say clamp this time at animation time. Okay, so that's all of what that is. And then let's just like align all of this. What's the next thing we do? Calculate the fraction of time passed. Calculate like the keyframe fraction. To me, this makes sense. Hopefully, it makes sense to others. I.e., 0 at the start of an animation, 1 at the end. Okay, what's this? So just say here, can't cast a vec3 can't cast vector 3 F32 in I8 to vector 3 F32 in Zig version 0.11.0. This has been fixed in the dev though. Well, okay, so really you can't cast this to this with at float from in. Okay. So then we have this manual crappy version, but that's okay. Okay, and then add in 0.5 offset so that the cube sits on the squares of the grid. And what's this? To put this code somewhere sensible, well, we kind of have done that. And now, depending on the animation fraction, offset the position of the cube. There's what we're doing. So I should really say as follows. The center of the cube during rotation moves on a circle of radius that with that. Okay. And then we got I feel like this stuff should also be replicated for theta 1 as well. like in fact we should do all of these together. So put that there, put this here, and then just say what theta1 and theta2 are equal to and all of these things. So at t equals 0, theta1 should be 1 over 2 pi, and then it's 0. And then 3 and 4. Okay. What's this step doing? Yeah, calculate the animation offset. Well, the center of the cube offset. Okay, and then what now? Yeah, we are calculating that animation rotation with this stuff, and then we finally, well, this stuff here should be happening up above, like immediately after we do that, and then that's fine. Okay, this is way better. This is the best this section of the code has ever looked, and we've worked on this like 2 hours or something. Okay, collectively. So let's check it compiles again. Not quite. 307. Okay, and it's working. So yeah, let's continue to go through this. Let's save what we've done. Yeah, what do we do? Just lots of cleanup. Main continued to clean up. Okay. Back to the cleanup. Now it's the render function. We begin drawing, clear the background. It's clear this is drawing the grid. We should comment this. Calculate the overall cube rotation. Both from its final position and the animation rotation. And then I see, yes, the 2 steps also added. The nice thing about the code from this thing we bookmarked, so if I do like this one, is that you can share code between 2 and 3D vectors, and it uses SIMD. Oh, yeah, that's really nice. Yeah, Odin, that's the same with Odin, I think, generally. There's just like a general intrinsic or polymorphic function that adds all vectors, that scalar multiplies all vectors, that like does the dot product of these vectors and everything. Yeah, this is nice. Okay. Oh, yeah, I haven't, my experience using SIMD stuff with Zig is 0. And so it will be likely I need to use it in the future. This will be a very nice reference. Yeah, thanks again for that. Okay. So we do this, and then finally we want to like render the cube. Do the yellow. Done. Okay. Now we have this, yeah, like raylib interfacing functions, and then the main like render cube drawing function. So all of this stuff here can disappear now that the cubes are getting drawn with a single color. Okay, so a caveat with this is that it's a bit incomplete. I mean, sure, but this is at least an outline, and like an outline is way better than nothing. And it's an outline with examples as well. Like you even have some test cases in here. Like, this is great. I'm happy with that. Okay, so yeah, construct triangles for the top of the cube and then rotate these around to get the other faces. Do that. Points for the face triangles, these ones. Points for the edge triangles, these ones. And then the face triangles and the edge triangles. Yeah, I'm happy we cleaned this up. Like, looking at this, I'm happy that like we defined exactly 4 triangles and then we just like rotate them around to all of these other positions. It's like, there's no need to like define a bajillion triangles here. 4 is enough. Okay, and then yeah, for the top face edges, yeah, we get edge rotation matrices. These ones, face rotation matrices. Okay, and then yeah, these ones, we're just adding the 2 together. I guess this is more explicit than just, and it's short enough that we don't need to rewrite this as like top face triangles or something like that. I guess, wait, that's literally what it is. Okay. Okay. What's this thing? Where are we using this? Multiplying everything in here by. Oh, wait, what is the rot though? But what if this thing isn't being used? The compiler would error. But it's not. Why? We're doing like draw cubes, like render cube. Yeah. Like, where's this getting? Oh, what is this? We can get rid of this one. No. So now we want to call this, what is it, like rolling, what's the rolling cube demo. Rod 2. So it's really just this rod is what I want. Oh wait, rod is like the thing we're passing into the function. Okay. In such a case, we should really put this at the top to avoid this, and we should just say scale the rotation by yeah, by 1/2. Okay, we are nearly done. Oh, two-step also says, since the intrinsic uses an external struct, they can be bitcast to arraylib vectors. Oh, if you know how to like cast stuff to arraylib, I want to know some shortcuts. Because currently the way that I'm doing this is with these functions that we should move to the bottom, actually. Right down here. Where like, I have this vector which is just a Zig's vector type, and then I want to get Raylib's vector type, and I'm literally just saying the x in the Raylib vector type is the 0. If you know of a way to like simplify this, please tell me. This is, I find this stuff just doing this is just really annoying. Okay. So I guess I've never actually used bitCast before. So how does this work? Converts a value of one type to another type. The return type is, oh, okay, yeah. So this is literally just saying, yeah, like don't change the like underlying ones and zeros. Just interpret this as something else. Okay, let's try this. So let's, instead of returning this, we just want to return what, bitcast vec, and give that a go. Oh, great! That's incredible. Okay. Okay, so that at least simplifies that function. Okay, when do I call this at all? I call it a couple of times, but it's small enough time that I can literally just bitcast this. Okay, so this constant one, control RT at bitcast, and then, oh, I can literally just do a find and replace. What am I doing? Vec3. Okay, so it's called vec3 to Raylib, and we just want to replace this with bitcast. Okay, that would have been the easier way to do that. Okay. Okay, we need to say these are vec. How does the compiler not know that these are Raylib vectors? The type of these in the struct is Raylib. Okay. This is still better than what was there before. So Raylib vector 3. Raylib.vector 3 equals enter. Okay. Oh. 2, 3, 5. Oh, oops, those are colons. Okay. Yeah, okay, maybe it's just that I'm using the version 11 of the compiler, and in version 12 there's no need to say this. Yeah, I don't know. 3 to 5. Well, what's this issue? Expected semicolon after statement. Yeah, okay, I see what I'm doing. Yeah, how do we get around this? Do I need to like say like as Raylib? No, this is like that's nasty. That shouldn't be. Like, yeah, do you know what I need to do two-step in order to get the compiler to go to know what to do here? Yeah, like it comes up with this instead. Oh, that's fine. Okay, that did work. Maybe I just didn't save it before. Sorry. This stuff needs to know though. So now we want to say Raven.vector 3. Okay, great. Yeah, colors are working. Now we can get rid of this. Okay, this is like a good thing to remember when version 12 is released and we remake and we update the previous projects to work with the final version 12 compiler to just bitcast away all of this stuff. Okay, that is really good. Oh, hang on. Before we do this, we want to bitcast the RLC here as well. So do bitcast. Does this compile? Okay, it does. Great. So now we can use it there. Bitcast. So now we can get rid of this. Okay. Aha. This makes me happy. Deleting lines of code always feels good. We run off the grid. Okay, git add main.zig commit cleaned up code. Using @bitstep @bitcast. Good. Okay. Git push. Okay, so I see some question marks here, so let's fill this in. Where is this located again? This is being located at rolling cube demo. Copy, paste. Well, this is it's unnecessary. Okay. Yeah, do we even need this anymore? We do, okay, we do. This can be yeah, matrices here. Now we've got the game globals and the animation stuff. This can be that. For that to be that. Yeah, there is generic support because we implemented that below. So here are some versions of common linear algebra functions. There, fine. We could say, oh, why is this randomly here? This is a global. This should go in the globals. Good thing we read through this one more time. Something I haven't been doing with any of the other projects. This should go under animation. Okay. Do that, do that. I guess we can shorten that loop. Do this thing. Apply these animations. It's really like compute animation. We're not actually applying it. Like we're kind of computing it and applying it. So I should say like compute and apply animations. Compute and apply animations. This one, yeah, do that. The procedure which computes a bunch of triangles which Raylib then draws. Okay. All of this stuff. I saw like, did I see a gap in here? No. Okay. Git add main.sig. Oh, we need to add like a README file. Finished cleanup. Okay. Off to GitHub. So the current README is really empty, like dangerously empty. So what should we do? Let's just copy what we did in the Sudoku project. This will at least give us somewhere to start. Okay, and so let's call this like rolling cube demo. Where's our rolling cube? I want to see another rolling cube. Git zig build. I feel like maybe it would actually be good practice, like building a since I'm not posting this anywhere than GitHub, like building an executable and maybe actually adding that as well, like adding a fast release build. Okay, so if we do zig build deoptimize equals release fast, that will do that in the background. And then yeah, we really need to like update all of this. This is just a simple demo in which a cube is rolled around the grid. We should include a screenshot nonetheless. Oh, instead of a screenshot though, this time I want to try making a like a GIF. Is it called like a GIF, whatever it is? Using that instead. But first of all, let's go into the zig out, get our fast version, and copy this to like oh, we need to actually change the name of the build file as well. This is like a weird name of the it's now a rolling cubes demo. And here run is just like run the demo. Anything else we need to change? I think that's it. Okay. Does it still? Okay, it's gonna do its thing, but while it okay, it's working. So we'll do another release fast build. Oh, but first, we go to zig out and the bin and the binary. Let's just remove everything in here. Can I just do that? Remove that. Okay, it's clear. So now zig build, this one. Okay. Fast one happening. Yes, because we did save it. Yeah. Okay. Now we can copy it. So now zig out binary rolling cubes demo to rolling. It's not really rolling cubes anyway. It's just rolling cube. Rolling cube.exe. Now if we run rolling cube.exe, it happens. Great, like we wanted. Oh, Stutep says, I discovered Raylib has a CMake build file for Wayland. Do you use Wayland, I think, but Raylib's build.zig doesn't seem to support it yet. Oh, curious. This is good to know. Let's look this up. So, do you use Wayland? So this is rolling cube here. I see it in like Rust Clang stuff. So Raylib DUs underscore Wayland. Oh, okay, yeah. What is... Oh, right, but it's, yeah, you're right. It's in here, but it's not in, yeah, it's just not in the build file. Oh, so then we could add it. Okay, so yeah, if we go to build.zig, for the flags, yeah, currently we're just compiling it with those. So, suggestion, do use Wayland, okay. Could be added. Okay. Gameplay, well, this is just like keyboard, simply like press the arrow keys to control the position of the cube. Note how the cube's position, how the arrow keys, how arrow key input is not blocked when animations are still playing. Now, like, this isn't the only reason I made it, but it's one of my pet peeves. It's so annoying when games do that. It's like so annoying. Okay. Yeah, build instructions. This should all be the same, and then the dependency should be the same as well. Okay. Oh, but we need to do a screenshot. So let's what's in here? So now we want to. Okay, let's just I want to clean up some of this as well. So now if we do rolling cube.exe. Oh no, but yeah, we don't want the screenshot. We want to do the GIF instead, which I've never recorded before. So how do we even go about doing that? Yeah. Thanks for the suggestion. Yeah, it's maybe for the next kind of project I do, I'll figure out how to change the icon from from the default thing at the top. I think this is something which Odin doesn't natively do as well, I think. One time I built something with Odin and yeah, it took me an hour or something to figure out how to do it. And then I think in Jai though there's a way to do it as well that's simple. But hopefully it comes to Zig sometime too, if not already. Okay. So okay, so first of all, does image magic convert say an MP4 to a GIF? Oh, it can. This is okay. Do I have Fmpeg installed? Maybe I don't. How do I tell if I have Fmpeg installed? I feel like this would be standard enough that some version of it would be on this computer. Okay, in either case, let's just record an MP4 and then figure out how to do it. Oh, I'm not sure OBS will be able to handle recording this stream and recording this at the same time. So maybe Windows will just I feel like Windows has a game capture, is it this thing here, or where is it how do you do this? How do I capture a MP4 of a game on Windows? I'm worried doing this is gonna stuff up the stream. Okay, it's activate the LRM. I don't want to read through that. Okay, Windows key and G to open G-bar while the game is running. This basically is a game. Okay, this is here. So now, what's the next step? Select the capture button and start recording an MP file. Okay, so if I do G, and then that is what I want. Oh, that's a screenshot. I want the video. Is this it? Start recording. Oh, to start a new recording, stop the current recording. Start again. Okay. Start. Okay, it's recording. Okay, maybe that was excessive recording. We can do better. Let's just do like 3 seconds. Okay, record. 1, 2, 3. Okay. Okay, and then where is this? Where are these located? Open file location. What a ridiculous prompt. Continue, like, of course. Of course I want to do that. Why else did I click on it? Okay, so let's see how this one. No, where's VLC? Why did that not open with VLC? Open with, choose another app. Always. Okay. Yeah, that's fine. Can I play that one? That one's way too long. Okay. Let's get rid of... What's this one? Yeah, let's get rid of these. We can just say this one is rolling cube video. Oh, it's annoying my mouse cursor is there. I don't want that there. That's really annoying. Let's get rid of that. Clearly that's like selected, and then record. No, what am I doing? That's the one we didn't want. Okay, better. This is what we want. Okay. Rolling cube. We'll just leave it as rolling cube. Okay. So now, like the image, what was this image magic command? The command, we can get rid of this now. The command is apparently... convert this where x is the desired frame delay in ticks, 1 out of a second. Okay, well, let's just see if this even works. So now we want to say image magic convert delay, and if do we want like a frame delay of like 50 per 100 seconds? Rolling cube.mp4 loop 0 test.gif. Okay, it's doing something by the looks of it. Okay. Okay, something's being made. Is this destroying our CPU? Don't like that it's using 50% of it at all. This is like too much number crunching. It shouldn't be doing this. How much did it do anyway? Can iframe deal with this? Okay, let's maybe not. Not seeing anything either. Time to just activate the LRM. How do I use image magic to make a GIF with 2 frames per second? Okay, so it's meant to be like a really large number then. So you need to calculate the appropriate delay between each frame. So for a target of 2 frames a second, the delay would be this is what we want. This is what we want. So I understand that the default ticks are 1/100. So like, why isn't there an option called FPS? Like, the image magic tag should just be FPS number. Like, how many frames a second? Okay, so it's still unclear what this even is. Okay, so the LOM says like to 500, but I don't know where this number 1,000 is coming from. It looks here that the number's 100. The default is 100 ticks per second, or what's n over 100? Oh, okay, so here it is. This is what we want. So we want the FPS is 100 divided by the number. So we want to insert 100 apparently, and then just get 1 frame a second. Oh, but it shouldn't. Why on earth was it taking that long to compute it? This is literally should just be taking like 7 screenshots. Why is my CPU dying with this operation? This is concerning. Dude, how is this like using 2 gigs for like a computation like this? This makes no sense. No, we can't do this. This is not allowed. Maybe there's actually some online tool that does this. Convert MP4 to GIF. I guess like Convertigo. This. Just use this. Choose files. This one. To convert. This is 4 megabytes. How is this program using 2 gigs of memory? Something's wrong. Something was wrong. So let's go back to this then, and see if this works. Yeah, this is what I wanted. Great. That's all we need. So now let's insert this into the thing, the README. So copy, go to this, paste, and now can I just include rollingcube.gif in the README? So we have this PNG. Now I want this to be rollingcube.gif. And this is what? An illustration of the demo, showing a cube rolling. Showing a yellow cube rolling. Okay. That, I think that's okay. So now let's, what do we change? We need to add the rolling cube gif in our README. Updated README. And then we want to add the build.zip file, and we also want to add the our like fast executable. Git add rolling, provided it's not too large. I mean, it's 1.4 meg. That's fine, I guess. Rolling cube.exe. Git add force. Force add this. Added build. What is this? Like updated build file. Added fast release for Windows. Okay, this will go onto GitHub. Let us check to see things. Oh, great and fantastic! The GIF automatically works. This is another thing to keep in mind for the other projects as well. Then I should add in a GIF to the GitHub, the READMEs for the other projects too. But great, that's working. And so I think that I'm kind of done with this project. Period. Like well, yeah, let's quit this. Let's clean this stuff. No need for these temporary files. But yeah, we wrote from scratch a program that rotates this cube around this grid. And yeah, and we didn't need to use quaternions. We didn't used to use any external libraries. I'm not counting Rayleigh as external. It was just like computing a bunch of triangles and then getting those to render. Yeah, so I think that's kind of it for the stream. Yeah, thanks everyone who stopped by and who said hi. Thanks especially to Steph for your help as always. Yeah, it's super cool now knowing that the bitCast is a thing that converts the stops all of the previous crap with Raylib. That the build file, in the build file we can add in this extra flag to like add an icon to these windows, and then yeah, the other suggestions as well, the intrinsics, that was really great, and also the link to your intrinsics thing as well. But yeah, yeah, just in case like anyone is like watching and who hasn't like seen this before, all of the code I do on stream is publicly available on GitHub. So if you just go to my username, just click Rolling Cube Demo, you can just download all of this, compile it, it should behave like this. And then here you can find other projects I did as well. I made a short app to help me learn a bunch of names of butterflies. And then to build a base for grid-based puzzle games, I also made something like this as well. But yeah, that will be it for me for tonight, I think. So yeah, thanks again. And yeah, hopefully I'll see everyone. Oh, before I go, Two Steps said, yeah, bitCasts needs a well-defined memory layout. Okay, yeah. Yeah, and yeah, I guess in the vector 3 and vector 2 structs in raylib, these are just these would be aligned appropriately. There wouldn't be any weird kind of gaps in them. So, yeah. But okay, see everyone later. Thanks again, Two Step. Bye.